From question A, the object is released from rest and slide down along the smooth ramp as shown. From question A, we need to sketch the FBD of the object. This is our FBD. There is a weight acting downward due to gravity, and N is the force acting opposite the weight. From question B, the question asks to calculate the speed of the object before it leaves the surface B. TA is the kinetic energy. Total U AB is the potential energy at point A to B. 1/2 MVA square root becomes 0 because it is initial velocity. Then we substitute the value into the change of y. Next, we calculate until we get the value of the speed of the object just before it leaves the surface at B. We get velocity at B 7.004. From question C, we need to calculate the distance from the wall of the ramp at B to where the object strikes to the ground. Firstly, we use the horizontal equation of motion to get the value. Next, by using a vertical equation of motion, we substitute the value to find the value of TBG and substitute back into the XG. Then we get the distance. Question D asks to compute the speed when the object hits the ground. By using the same formula in principle of work energy, where TA is the kinetic energy and total UAG is the potential energy at point A to G. We substitute the value back into the formula and get the final answer.
Question 2A. Calculate the velocity of the object just after it rebounds from the ground. The object falls from point A to point B due to gravity. The object then falls to the ground with velocity from point B, in which I name it as velocity ground 1 or VG1. The object then rebounds to the next point due to the hitting impact and create another velocity, in which VG2. The question asks us to find for the VG2. So we use the vertical equation of motion for y component, which is VGY1 square equal to V1y square plus 2a times with SGY minus S1y. The SGY is the initial height and the S1y is the final height of the first bounce. It is negative because the ball moved downward to the ground and opposites of our assumption here. So the value for the vertical equation of motion for VGY1 is negative 4.43 meter per second. And then we use the coefficient of restitution equation. E is already given in the question, which is 0.7, and VG2 is 0 because it is initial velocity, and we need to find for the VGY2. VGY1 is negative 4.43 minus with VG1, which is 0. And then we get the value of 3.101 meter per second. And then we use the conservation of linear momentum equation to find for the VG in the X component. So after substitute all the value, we get the answer of 7.004 meter per second. And then we combine both of the answer in the vector direction. From this vector direction, we can get the magnitude of the Vg2, which is 7.66 meter per second. Question B. Compute the maximum height to which the object rises after the first bounce. Question B asks to find the height, so we use the kinematic equation, which is the vertical equation of motions. And after we calculate, we get the height is 0.49 meter.